Okay, so today I'm going to be looking at some data from Spotify, and I'm going to be comparing music that we listened to in quarantine versus like music we listened to last year. And I can do this because Spotify has this really cool API that is available to all of you, and you can look into further. And I'm going to use this Spotify. Uh, Library module, I'm not sure. But the documentation is also available to you if you want to look into it. So this is just an example of kind of a short little data project. Um, and I am going to give you sort of a broad overview of what's going on. I'm not going to get too detailed about a lot of this code because it is very specific to Spotify. A lot of it is. So I don't really want you to get too hung up on the details. So let's get into it. So this first cell, my client ID and my client secret were things that I had to register this project basically with Spotify's API, um, and they called me a software developer, I think, which is a real loose use of that term. But if we run this cell, we can see this here. So I just included this cell. This is how you download Spotify. Um, I already have it downloaded, but if you want to do it yourself, this is how you would do that. I'm also going to import pandas, numpy, matplotlib for my visualizations, as well as Spotify. So that's what this cell is doing. This is all my imports. Um, SP, I'm basically setting this equal to Spotify data in bulk. And now we can get into the kind of actual code. So here, hopefully you'll recognize a for loop. So we're going to go through this list of terms. And so I'm going to say for each term in this list of terms, I'm going to search Spotify for playlists containing this term. And then for all of those, I'm going to count all of the playlists that contain this term and then print it. So that's what total is doing. It's an aggregate. Well, actually, yeah, it's taking the total. So I'm going to do that for each of these terms. If I run this cell, I see that I have about 8,000 for COVID, about 9,000 for Corona, and we continue on. So now I'm going to define this function called batch processes, which what it's doing is it takes two arguments and most generally it appends information about each playlist to a list. So what I'm going to do is I'm going to create an empty list and I'm going to append all of this information into this list of playlists, which is an empty list. So that's my list. This, I called it init data. It's going to be my X. So my init data is going to be my list of playlists. And this is actually the exact same line of code that we saw up here when we were searching. But here I've decided that I don't want to go through this whole list again, so I'm just going to choose one term, and I'm going to replace term here with COVID. So that was just a choice I made arbitrarily just to make things a little simpler. Okay, so when I do that, I'm then going to, so now I have list of playlists. It's no longer empty after I run this cell, and I'm going to turn it into a data frame. And you can see that here. So we have the name of the playlist, the total number of songs, and the URI. And we can see that all of these playlists contain COVID somewhere in their name. Okay, so the next thing I'm going to do is I want to analyze the songs actually contained in each of these playlists. So in order to get the songs, I'm going to extract them from each playlist. So that's what this for loop is doing essentially. So I have an empty songs list and I'm going to, again, append the track and the URI onto this list. And then I can make a data frame of this list of songs. So that's what this is doing here. And I can see it. Okay, so we have the URI for each track and the count. So this is how many times this song appeared in all of the playlists that contained COVID somewhere in their name. So this Spotify appeared 23 times in however many playlists we were looking at, around 8,000, I think. So I'm actually going to make a histogram to see the distribution of the number of times songs appear. So we can see most songs appear like one or two, this is probably one time um, in these playlists. So a lot of uniqueness in these playlists, but there are a couple that are um, greater than 5, go all the way up to 25. I specified that I wanted all the songs that were greater that had count greater than 0 or less than 50, and you can see it only goes up to 25. So 50 was a bit of an overestimate. Um, but I just wanted to be sure that I included everybody, so we can kind of see that you it is really hard to tell, but there's probably something in here if we went all the way up to 25. So I'm interested in the songs that appeared more than 5 times, so I'm going to specify that. And then for these songs specifically, I'm going to apply this function that I defined, which is data enrich, which will take a track's URI and it will add all of this information about it from Spotify. So I can do that. Here I've applied a lambda function. I think we taught you guys these. Basically, lambda just assign. It's like what is it like? It's like applying a function to a lot of data in an easy way, almost like a list comprehension or a for loop, but you can write it in this really nice, compact way. So that's what I did. I applied this data enrich to all of the songs that appeared more than 5 times. Um, then this is now a data frame, so I'm going to drop a couple columns that I don't care about. And then I'm going to sort by count, ascending equals false, so I see the most used song first. So if I run that, I will get this data frame, and we can see that sicko mode appeared 24 times, which is kind of fun. So you can see that all of these song names make a lot of sense that they would appear a number of times in a quarantine playlist. People are funny. Yeah, good stuff. Okay, so we'll just kind of go by. You can see there's a lot more rows. And this was just songs that appeared more than 5 times, so I kind of limited it. But I wanted to get a sense of like what a lot of us are listening to in quarantine, so that's why I did that. Okay, so now I'm going to look at top 2019 songs. So I took a playlist containing like the hits on Spotify in 2019, and I applied basically the same for loop that I used before, except now I'm appending to a different list. I'm appending to this empty top 2019 songs. I'm going to apply the same code to it, and I'm going to make a data frame. And so now I see we have the URI and the count. The count is meaningless at this point because each song will only appear once in the top 2019 playlist. So we can kind of ignore this. It doesn't, not very helpful. I'm going to do the same thing. I'm going to apply data enrich. I'm going to collect a lot more data on each of these songs and drop some more columns and finally come up with this table. And you can see all of these songs are super familiar from last year as well. Okay, so we'll go by it. And finally, I'm going to wrap this up with some visualizations that compare the two. So let's look at some of the things. So we added data enrich, and we just from the URI, we were able to collect all of these attributes, which are pretty cool. So a lot of these have to do with the music itself. So somehow Spotify decided on metrics for all of this. You can read more about their methodology, but they have these attributes like acousticness, danceability, instrumentalness, and speechiness. Love that. Valence, all kind of fun. So I'm going to look at two right now and use two different visualizations that kind of explore the state a little more. So the first one I wanted to look at was valence, which is a metric of positivity, basically. So I wanted to compare positivity in songs that appear a lot in our quarantine playlist and the positivity of our top 2019 songs. So if I run this cell, I'll plot a histogram of valence for each. And you can actually see that our COVID songs are in blue, and the frequency of scoring a high valence score is actually much higher in these COVID songs. So we are apparently staying positive, which love to hear. And you'll remember that a histogram just has frequency on this y-axis, so no need to worry about that. But yeah, you can see valence down here. Okay, so that's kind of a neat finding. The next one, I want to compare danceability, and this time I'm going to use a box plot to do so, which tells that they're both plots of distribution, so just two ways of kind of looking at a similar thing. So here we go. We have um, COVID and we have top 2019, and you can see that the 50th percentile in this top 2019 category is pretty like you can see quite obviously that it's higher than our COVID songs, which makes a lot of sense because social distancing doesn't lend itself to a lot of dancing. So maybe not a super surprising finding, but kind of fun. So I invite you all to play around, sign up for your Spotify, yeah, install Spotify and maybe look at your own data. Kind of cool. Sorry, I just scrolled a lot there. Okay. Hope this was fun.